First thing we're going to do here is go over the equations. The equations are very similar to the last ones. The only thing that's going to change is delta x becomes delta y and a becomes g. So first equation, delta y equals 1 half vf plus vo times t. Next one is delta y equals vot plus 1 half. That just didn't go well. 1 half gt squared. And then we've got vf equals vo plus gt. And then vf squared equals vo squared plus 2a or g delta y. So I'm just going to write down the g and delta y. G is always going to equal, at least on Earth, negative 9.8 meters per second squared. And it does vary with altitude, but it always rounds to that. And then delta y, how far it's risen or fallen. Oops. And we say if it's rising, it's going to be positive. If it's falling, it's going to be negative. Does that make sense, everybody? I'll give you. This one says, the ball is thrown up with an initial velocity of 12 meters per second and caught at the same height. First thing I want to figure out is how high does the ball go? So this is going to just be like the up portion of it, just going up to the top. Does that kind of make sense? We're going to be going up to the highest point. We want to figure out how high it is. All right, so that is up. What do we know about going up for this part? Initial velocity. What else do we know? Yep, so g is our acceleration is negative 9.8 meters per second squared. What else? What's the final velocity? 0. At the highest point, final velocity is going to be 0. Everybody remember that from the notes? Alright, so for part A, we're looking for delta y. So what equation for delta y do we have that has all three of those things in it? The last one. So we're going to use vf squared equals vo squared plus 2g delta y. And we'll solve that for delta y. Actually, I'll write the numbers there. So we get 0 equals 12 squared plus 2 times negative 9.8 times delta y. And what does delta y equal? .35 meters. So that's the answer to part A. I'm going to shrink that down a little bit. Alright, so now figure out how long does it take to reach the highest point. So for part B, we're looking for time. So to do time, we want to use the ones that we were given, not the one we found, just in case we got the one we found wrong. So we're going to use VF equals VO plus GT. So you get 0 equals 12 plus 9.8. That should be that. plus negative 9.8 times t. What does t equal? 1.26? 22 seconds. So that's the answer to part B. All right. Now, we're going to figure out how long it takes to fall from the highest point. So this is going to be the down portion. What do we know about the down portion? Initial velocity is 0. What else do we know? Acceleration. And we know one other thing. Delta y. What's delta y going to be? Negative 7.35 meters. Any questions about that? It's lower than where it started, so we're going to make it negative. So it's displacement, not distance. What? Just a second. We'll get there, Dean. Just be patient. Okay, so we're looking for time. And for part C. Okay, so the equation we're going to use is delta y equals VOT plus 1/2 GT squared. So we get negative 7.35 equals 0 plus 1/2 times negative 9.8 times t squared. And what do we get for t? All right, 1.22 seconds. So it takes the same amount of time to go up and down as long as it's going to the same height. That'll be useful to you. And D, I'm not actually going to do any work for D. What do you think the answer to D is going to be? Yep, it's going to be negative 12 meters per second. So when you throw something up and down to the same height, it takes the same amount of time to go up as it does to come down. When it comes down, it's going equal speed but opposite velocity. Make sense to everybody? Any questions? First problem. This one's a nice, easy way to start. So, what do we know about this problem? If it's dropped, what do you think the initial velocity is? 0. What else do we know? G is equal to negative 9.8 meters per second squared. What else do we know? Delta y equals negative 30. And we are looking for final velocity. Alright, so what equation has these four things in it? Last one. VF squared equals VO squared plus 2G delta y. That looks like an x. So we get VF squared equals 0 plus 2 times negative 9.8 times negative 30. And what do we get for VF? What was that? 24.25 meters per second. We took the square root of that to get there. What should be in front of there mathematically? Plus or minus. Is it going up or down? Down. So what should this be? Negative. So when you use this equation to find final or initial velocity, you got to be careful and think whether it's supposed to be going up or down. Most of the time it should be relatively obvious, like at the end here, if you drop a stone, it's not going to be going up. So you're going to use negative. So our answer here is negative 24.25 meters per second. if you threw it up from a cliff, it could be hard. You maybe you may have to like do some other math to figure it out for certain. Any questions about this one? This one, there are multiple ways to do. I'm going to describe the first way to do it. So let's draw a picture here. So ball goes up, ball comes down, hits the ground. We could break it apart into different pieces. And this is 15 meters high. We could figure out how high it goes above there, figure out how long that takes, add 15 to that distance, and then figure out how long it takes to hit the ground. Does everybody see how you could do it that way? Easier way. We can just do it all in one big step. So what we're going to say is we're going to say, how far is it from where it started? What's its vertical displacement? Negative 15 meters. We know g is equal to negative 9.8 meters per second squared. And initial velocity is 18 meters per second. As long as we use that information, we can just find the time, and that'll be our time. All right, there's still two ways to do this. You guys want to? Well, I'll show you both ways. First way is going to be using the quadratic formula. Second way, we'll do two parts, and I'll manage to avoid the quadratic formula. So first way, we can say delta y equals VOT plus 1/2 GT squared. We get negative 15 equals 18t plus 1/2 times negative 9.8 t squared. And for that, we'd have to use the quadratic formula, right? And you guys could do that. The other option is to do two equations. So we'd have to find the final velocity first, and then use that final velocity to find time. So we can say VF squared equals VO squared plus 2, this is an or, G delta y. So you get VF squared equals 18 plus 2 times negative 9.8 times negative 15. And when you do that, what do you get for final velocity? Do you remember to take the square root of that?
17.66.
Oh, I forgot to put a squared right there. Sorry about that. My fault. What is it, Elise? 24.86 meters per second. Should that be positive or negative? Should that be positive or negative? Negative, because it's plus or minus, because it's going down when it hits the ground. Alright, so once we have that, we can use VF equals VO plus GT. So we get negative 24.86 equals 18 plus negative 9.8 times t, and we solve for t, what do we get? 4.37 seconds, and that's the same time we would have got if we use a quadratic formula over here. Dean?
Why wouldn't you, in the first way you do it, why wouldn't you put negative 18 meters per second?
Because it's thrown up initially. So you're throwing it up, so your initial velocity is positive. If you threw it down, initial velocity would be negative. That make sense? Any other questions on this one? Alright, So a rock is thrown downward from the top of a cliff with initial velocity or initial speed of 17 meters per second. If the rock hits the ground after 2.7 seconds, what is the height of the cliff? So what do we know here? Initial velocity is negative 17 meters per second. Time is 2.7 seconds. And what else do we know? G is equal to negative 9.8 meters per second squared. So what equation do we want to use with these? Second one, so we're going to say delta y equals VOT plus 1/2 GT squared. So we get negative 17 times 2.7 seconds plus 1/2 times negative 9.8 times 2.7 seconds squared. What's delta y equal? Right, so when you do that math, you should get negative 81.62 meters, but the height, if you're looking for height, it would just be positive 81.62 meters. I'd accept usually the negative version of that as well if you put that on a test or something like that. Any questions over that one? All right. This one's a little trickier than the other ones we've done. So a falling stone takes 0.43 seconds to travel past a window 2.7 meters tall. From what height above the top of the window did the stone fall? Any idea how to start this one? There's an unknown height. It stops. The problem stops at the end of the window, so it's just above. So it's going to be one part or multiple parts? Two parts, right? So we're going to have above the window and window. What do we know about the above the window part? Initial velocity is 0. Yes. It should say from what height above was the stone dropped or something like that. We know anything else about the above the window part? Nope. What do you know about the window part? Delta y equals positive or negative? Negative 2.7 meters. What else do we know? T is 0.43 seconds. And what else do we know? G is equal to negative 9.8 meters per second squared. Alright, so we can solve stuff with the window part. How does anything in the window part relate to the above the window part? The initial velocity of the window part is going to be the final velocity of the above the window part. Make sense? So we're going to say use delta y equals VOT plus 1/2 GT squared. So we get negative 2.7 equals VO times 0.43 plus 1/2 times negative 9.8 times t squared. And we know what t squared is, though. Times 0.43 squared. So what's our VO equal? Alright. Alright, so our answer is negative 4.17 meters per second. So that's our VF for this part. So now we're looking for delta y, so we're going to use VF squared equals VO squared plus 2G delta y. So you get negative 4.7 or 17 quantity squared equals 0 plus 2 times negative 9.8 times delta y. Get for delta y. Anybody? Negative. Yep. Negative 0.89 meters. So the height above the window, if we were looking for just height, 0.89 meters would be our answer. Any questions on that one?